One of the things we like to do when we have single variable information, they use this fancy word univariate, uni meaning one, so single variables, I like to say single variable, is to find out what does the distribution look like graphically. So if you kind of recall way back, when we were talking about, I think we were talking about averages, we set up this dot plot. And we can set up a dot plot for this data right here. And I can see that my lowest number here, it's hard to find, what is it, 29, 28. My lowest number is 28. And my highest number looks like, it's 72. So I could set up a graph that started here at 28, 29, 30, 31, 32, 33, blah, 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 all the way until we got up here to 72. And then I could kind of take each piece of data. Well, I have a 62, so that would go there, and I have a 52, so that would go there. And I would end up with this graph that just looked like a bunch of scattered dots, because each line represented just one data value. So what we like to do instead is we like to group them. So instead of just saying like have one space for one column for the 28s and one column for the 29s and one column for the 30s, I might have a column that goes, say, from 25 to 30. So any number that falls in there would go into that spot. Or, and then if I'm going to do it by fives, this is called a bin, as you'll see why in a minute. So I'm going to do it by fives. I got to do it by fives all the way around. So I have from 30 to 35, 35 to 40, 40 to 45, 45 to 50, to 55. Oh, I'm going to run out of space. I made it too big. To 60. Well, let's kind of just stop there and know that it goes on. I'm sorry about that. You get the idea. So what I'm going to do here is I'm going to say, okay, so that's my x-axis. And I'm going to have a y-axis. The y-axis is going to have, well, there'll be one item in that one, or two items in that one, or three items in that one. So let's just see if we can't fill this in a little bit. So my first item is a 62. Well, the 62 would go into this bin over here. So that gets me, I'm going to put a little block there because that brings it up to the 1. And then my next one is a 52. So that means I have 1 in that space right there. And then my next one is a 38. Well, that goes into between 35 and 40. And then I have a 55. Well, 55 is a little bit confusing, right? Because is 55 going to go into this one here, or is it going to go into this one here? I have to make a decision. And it doesn't really matter which decision you make, but you have to make a decision as to whether the right side of the bin is going to be inclusive or non-inclusive. So in my case here, let's say this bin right here from 50 to 55, I'm going to say that that bin is numbers that are greater than 50. So x, oops, sorry about that. So my x value is greater than 50, and my x value is greater than or equal to 55. So that is going to go into 55 is going into this bin because it is greater than or equal to. So my right side of the bin is going to be greater than or equal to, and my left side is just going to be less than or equal to. I'm sorry, I don't mean to be confusing you, but I think we're okay. So that 55, now that means I have 2 in that bin. And now I have a 47. Well, 47 is between 45 and 50. And now I have a 42. 42 is between 40 and 45. a 32. That's going to be right there. A 46. Well, 46 is between 45 and 50. That's going to make that a 2. 29. That's going to go over here. So each of these numbers, 29, I just dropped it in that bin. This 46, I dropped it in that bin. And since there was already one on the bottom, it just sat right on top of it. So if we keep on doing this, what we're going to find is that we're going to have these different bins kind of at different heights. And what we're going to wind up with is a histogram. And a histogram, I mean, there's all different kinds of shapes of histograms, but maybe those of you who do photography, you'll see in your fancy cameras, there's this little thing with colors, and it looks like all these squares and things like that, blinking up and down and moving. That is a histogram, and it's measuring certain measures of light. But a histogram is going to look like that, and it's going to give us the shape of the distribution of the data. The key word here, the words, are intervals or bins. That's what we're making, and we're dropping each piece of data into the bin where it belongs. Now, the big question here is, well, how big do I make the bin? So let's take an absurd example. Let's say that I want to make my bin, and I want to start my bin at 0 and go all the way to 100. Well, every single piece of this data is going to fit into that bin. We're just going to have one big giant block, which just doesn't help us at all. We could take the alternate approach like we started with and have each bin be one single number, and then we're just going to have a bunch of scattered little blocks, you know, for each number, because each one represents one. Maybe we'll have a 2, maybe there's a couple of duplicates, but it's not really going to help us get an idea of what the distribution is. So the way that I determine what the bin size should be, or at least begin to start to get an idea, is I do what they're saying here. How do you know what the interval should be? How do you know what the bin size should be? Well, first I determine the range, and this would be 72, which is the highest value, minus 28, which is the lowest value, so 44. And then I start dividing it by numbers to just get an idea of what would be a good bin size. So in this particular case, they're saying, well, if you want to do just 2 bins, then each bin is going to include 22 numbers. That's not enough bins, or it's too many numbers in each bin. If I want it to be, if I wanted to have 10 bins, if I want to have 10 years in each bin, well, then I'm only going to have 4 intervals. There'll be too many in each interval. So here they said 8, and they said that's just right, because then I'm going to have intervals at every 6. You know, personally, when I'm looking at a graph like a histogram, let's look at their histogram. Did they draw it? Yeah, they did. Here's their histogram using their bin size of 6. So it goes from 25 to 32, 33 to 40, 41 to 48. So each of these is an interval, and there's 8 years in the interval. And to me, this looks awkward. I don't think very well in like 25 to 32, 33 to 40, 41 to 48. In this case, maybe it's necessary, but I generally like to have my bins in like 5s or 10s, because that's the way people think. People think in 5s and 10s, because we have 5 fingers on each hand and 10 all together. But it's really one of those things that you're just going to have to get used to, and it actually becomes a little bit of an art form as to decide how big your bin should be, the number of years in each interval, the number of items you want to have between these two lines. And part of it is going to be determined by what the histogram looks like when you make it. So you know when you get a histogram that just has one big box, well, your bin size was too big. If you get a histogram that has lots of little tiny boxes separated sometimes, then you know your bin size is too small. You want to get something that kind of looks so that it's giving you some information. It's difficult to do that on a lot of these problems because even though this looks like a lot of data, I mean, when we're really talking about using histograms for data, we're talking thousands and hundreds of thousands and millions of pieces of data, so it wouldn't look quite so boxy like this. But for the time being, it's just going to be something you're going to have to experiment with. So how do we experiment with that? Guess what? We're going to use the calculator. So what I did here was I did in L3, I entered in all of this data into L3. You can kind of see if I kind of go back up to the top now. I left my L1 and my L2. I'm not going to use them right now. That's the data we have from another problem. But I'm going to use L3. I could have cleared out L1 or L2. It doesn't really matter. So I have L1 and L2, and I'm going to go, I have L3 is the one I'm using, so I'm going to go second, stat plot. And earlier we had made a box plot, but I don't care about that right now. I'm going to use plot 1, and I'm going to get rid of my box plot. Plot 1 is still on. You can see it's blinking. That the on is the one that's on. And I'm going to hit enter, so I want to keep it on. And I'm going to go down, and I want to scroll over to the histogram. See, it looks just like a histogram. So I'm going to go over, and I'm going to hit enter. Now, my X list is in L3. That's where I put it. Second, 3. And I hit enter. My frequency, because all I did was I entered the data just straight up. I didn't see if there were any duplicates. I didn't want to do that and see, well, how many 32s do I have or how many 40s do I have and have a separate list for frequency. The frequency is just 1. Each item that I put in, I had just 1. Uh-oh, is that going to work? So when I pressed this the first time, I pressed 1, and it came out a Y, because that A is blinking. It was originally looking for an alpha. It was looking for a letter, like a L3. And if I want to make that A go away, I just press alpha, and now it's just a blink, and I put 1. I want to make a histogram graph. I'll push enter just to make sure it's okay. I'm going to go zoom. I get this little thing on the bottom. I don't know why it happens sometimes. I'm going to go second, quit, and I'm going to go zoom 9, my stat, and now I've made a histogram. And that's actually a pretty nice looking histogram. Now, let's see what the bin size is. I'm going to do that by pressing the trace button. So this is telling me my first bin is going from 5, that's a decent number, I guess, to 18.4. That's a weird number. My second bin is going from 18.4 to 31.8. Well, let's do something here. It was 18.4 minus 5 was the first bin, so 13.4 was the size of the bin. And this one is going from 31.8, 18.4, again, 13.4. So at least all my bins are the same size. All the bins have to be the same size. But 13.4 is a very awkward number for the size of a bin. I keep going over, it's going to be increasing by 13.4 every time, and I can see that I get to the highest number. Well, there must be something bigger than 72, and but less than 85.4. So the calculator will give you a bin size. When you go to write this out, it's an awkward bin size. So I would try something different, and the way you do that is this. You go into the window button. And the window button gives you your minimums, your maximums, and where it says X scale, that is your bin size. You notice it says 13.4, and that right there says 13.4. So the picture looked actually pretty good. I could maybe go with that if I wanted to, but I'm going to try what happens if I do a bin size of, say, because I like these round numbers, I'm going to do a bin size of 10. And I know that my minimum is not as low as 5. I think my minimum was somewhere around, let's see, where is the minimum here? I have 29, I have 28. Let's just give it a minimum of 20 and see what happens. And then my maximum, my highest number, the minimum has to be lower than your actual minimum. And my highest number is in the low 70s. I have a 72 right there and a 71. Let's give it a maximum of 80. And now let's go zoom 9. Zoom 9. Again, I have a pretty nice histogram there. I made a mistake. This is the repeat of the histogram. I got to go back and change my window again. So I was going from 20 to 80. Now it's going by 10. I don't press zoom 9. I just press graph. And now that's what my histogram looks like. I don't know. It's okay. The other one had a little bit more of a nice, like, bell curvy shape to it. This one, maybe not quite as bell curvy, but looks like that a little bit. Again, it's kind of an art form that you're going to have to develop and decide what bin size you're going to use. I'm kind of a stickler for using numbers. I'm going to push trace again here. That if I wrote them on a graph, they would actually make some sense. The main thing is that you understand what a bin is, and that the bins have a size. They have an interval size. And yeah, so if you kind of get that, you'll have a pretty good idea of how to answer most of these questions that would be like on an SAT. So based on that explanation, I would hope that you could then figure out what they're talking about in B and C here. So we're trying to make a frequency table for the data. And what we did is we have our bin sizes. We have one bin that's between 25 and 32, one that's between 33 and 40, one that's between 41 and 48. And so this means there's 3 items that fell into that bin, there's 4 items that fell into that bin, 3 items that fell into that bin, 7 items that fell into that bin, 1, and then 3. So we've kind of used the histogram and the frequency table and shown how they're really just different representations of the same information. I actually do think that the histogram that the calculator made looked a lot nicer than this one here. It is just so that the numbers were rather awkward. So again, it's a thing you just need to play with. Let's just one more time here really quickly show the relationship between this frequency table and the histogram. So in my 25 to 32, it has a frequency of 3. Well, here's my 25 to 32 bin right here, and you can see that 3 items fell into that bin. And in the 33 to 40 bin, 4 items fell into that. The 41 to 48, 3. The 49 to 56, that went all the way up to 7. So you can kind of see the relationship here between the histogram and the frequency table of the data.